Welcome everyone. In this video, we're going to be chatting about taking a current measurement with our multimeter or using it in the ammeter setting. Now, as hardware hackers, it's not as important to be able to take a current measurement, and unfortunately, it is actually pretty difficult to do on a circuit board. And the reason for that is that opposed to how we measured the voltage in parallel by measuring just across the leads or the pins of the component. In order to measure current, we actually have to insert our meter in series in such a way that all of the current is going to actually travel through the meter. So we take a look back at our original drawing that we did before where I was showing how to measure the voltage in parallel. I've put a break in that circuit here. And if we wanted to measure current, so we'll set it to this 200 milliamp reading here, then we would actually have to put our positive lead here and our negative lead here. And then all of the current, it has nowhere to go. So if I just kind of rest these down, you think of them connecting to those points, then all of the current is going to flow into the positive lead. It's going to go all the way through our meter, back out the black one, and then travel through the circuit and then back to ground. So opposite to our input resistance being really, really high when we're measuring voltage because we don't want any current to come through and alter the circuit, it is the opposite when we're taking a current measurement and our input impedance is very, very low. It's generally in the single digits of ohms, and the better your meter is, actually, the lower that resistance is, because we don't want to be having any voltage drop over it and affecting the rest of the circuit by putting something in series. So this is the reason that I'm chatting about this, even though it's not something we're going to be taking any measurements with, because this is how it's the easiest to actually damage the meter or blow a fuse. Now, the reason for that, again, is the input impedance or input resistance of this is extremely low. So if we were to close this circuit, so we just draw this closed circuit, and we were going to, try and measure the current that's coming straight out of that jack, and we're just curious about it. And we set, this to our 200 milliamps because we know that we think it's going to be around that. And we were to just then touch our leads here, so positive and negative, then I'll just draw out what's going to happen on this circuit. I already took a measurement, and I think in the manual, if you read this, it's going to tell you what the input impedance or the input resistance is. And when I measured it, it was just around 4 ohms. All right, so I'll just draw out the circuit, and we'll say that this is the probe, and it's coming down, and this resistor will signify our actual multimeter in that current reading setting, and it was 4 ohms. I can tell you right now, the impedance of the circuit is going to be much, much greater. So what's going to happen is when we get our current flow here, it's almost all of it is going to go through this top route, and it's going to come down through our meter. Now, if you just do the quick math on this, 9 volts, 4 ohms, that is going to give us a current of 2.25 amps, which we already know is much greater than our meter is fused for. So we're just going to blow that fuse immediately. And it's really easy to blow these fuses taking the current measurements if we're not doing them properly and we are doing them in parallel. So I just really wanted to quickly call that out. Now, again, so the reason that this is really challenging to take these measurements on the board is we actually need to break the electrical path or the signal path that current is taking. And there's no really good way for us to do that on a circuit board without actually damaging it. So if we wanted to, for example, interrupt the trace, then we would have to actually, we could take a knife and cut that trace, or we could, cut off the end of a component and lift it up and then try and connect between that. So there isn't really a good way to take a non-damaging measurement. And that's why we're not going to be taking any. As hardware hackers, this isn't super important. And just a quick reminder, of course, of Ohm's law and that we can usually calculate the currents as needed quickly mathematically. So I did want to just really quickly demonstrate, how you can use the multimeter to take a current measurement and just how to do it properly without just using this picture. So what I'm going to do is I'm going to bring over a quick little very basic circuit and show how we can actually take a measurement. Okay, so what I've got here, this is called a breadboard and it's used for prototyping circuits. So the way that it works is that on these lines that run perpendicular to the length of it, these are all electrically interconnected. So I have the power coming and it travels through this whole top line. And then I have the ground on this battery and it travels through this whole line right here. So what I've done is I have the LED, the positive end of it comes out to this line here, and then the resistor is in another hole, so that means there's a connection here. And then when I tuck this into the ground, you can see that the LED lights up. So very, very basic circuit. Now, if we want to measure the current from this, what we can do is I can, again, break this connection. And we're just going to grab a couple alligator clips, and I'll show you how we can put this meter in series. Okay, so what I've done is I've just broken that connectivity in that circuit and I've connected the alligator clips to each end. So if I touch these together, we should see this light up. Yep, perfectly, it lights up. All right, so if I put the positive end of our ammeter in through here, and then if I connect through here, this means we have it in series. And we're looking at about 11 milliamps flowing through this. So that's how we take that. Again, if this were on a circuit board, it would be really hard for us to do this because we would actually have to, either desolder these leads and pull them out, or maybe cut them and then use some sort of jumper. So there isn't really a good non-destructive way to do it. Before I wrap up this video, just a really quick reminder to be careful when you're taking current measurements. Make sure you have it in series because it is the easiest way for us to blow a fuse or damage our equipment. So that actually wraps up this section and wraps up electrical engineering for Hackers 101. So great job on making it this far. I will see you over in the next video where we will start over in the electrical engineering for Hackers 201 section, and we're going to expand on some of these fundamentals and look more in depth at some of the principles that we'll need to know for our hardware hacking. Thanks a lot. See you in the next video.